So I wanted to talk a little bit today about the limit definition of a derivative. So I've written it out here and let's just jump right into it. So let's say that we have a function f of x and it's going to be a smooth function or a continuous, or it operates on an open set, however you want to call it. And we're going to draw out like a little graph of this guy. So here we have f of x and here we have x, and let's just say that it looks something like this. Who knows? So really what the derivative is describing is the slope at a given point, or a tangent line. So let's say here, I don't know, and we have a tangent here. So what is the slope of this tangent line? Well, if this is a point, we're going to call it x1, I guess. How would we find out what the tangent is here? Well, what we can do is we can take another point on the function. So maybe here, sure. And this is going to be at the point. Maybe I can't define it precisely, but I can say that it's at x1 plus on some number. Don't really matter where it is, I'm just going to use epsilon here. And what we can do is we can draw a line through these guys. And basic line algebra tells you that the slope will be the change in y, so that's delta y, divided by the change in x. And what we do here is we make epsilon become a little bit smaller. So if epsilon approaches 0, then it's going to pretty much be at the point x1. So let's just write out what the change in y and the change in x will be. So let me just make a little room, get rid of this. So what's our change in y going to be if we go from here to here? So this is delta y and this is delta x. So our change in y is going to be f, so we're going to take this as the bigger one, so it's going to be f of x1 plus epsilon, and then the y coordinate for this point here is just going to be f of x1. And what's our change in x going to be? Well, it's going to be x1 plus epsilon minus x1, so it's just going to be something rather nice actually, because these x1s are going to cancel. And remember we said we're going to take the limit as this thing goes to 0, or as epsilon goes to 0, in other words as this point approaches towards this other point. So limit as epsilon approaches 0 of this guy. And if we notice, this x1 is going to cancel out with this x1, and that's basically how we arrive at our limit definition for the derivative. Yeah, thank you for watching.